Hello, and welcome to my lab report for Physics 2212 Lab 2, Charge Tape Revisited. This lab builds off of Lab 1, Charge Tape. In that lab, the purpose was to model the electric field generated by charging a piece of tape and treating it as a point charge. In this lab, however, instead of treating the tape as a point charge, I will treat it as a distributed charge, which is the sum of the charges of n pieces of tape. I didn't repeat the physical experiment this week, but the materials from last week are still the same as shown, while the fundamental principles in this lab continue to be Newton's second law, Coulomb's law, and gravitational force. These were the experimental values of the pieces of tape used last week, and in the computational models, this slide isn't as relevant this week, however. The same gravitational and electric forces calculated experimentally last week apply this week, with the force of gravity being equal to 1.962 times 10 to the minus 3 newtons pointing towards Earth, while the electric force is of equal magnitude but pointing in the opposite direction. In this way, the charge of the tape was determined experimentally to be 2.09 times 10 to the minus 8 coulombs. This is the computational model for modeling the tape as a distributed charge. To achieve this, I divided the length of the tape into n pieces. In this example, n is equal to 10, but it can be any number. Then the charge of each individual piece was calculated, and the sum of these pieces yielded the total charge of the tape. In this computational model, the charge in each piece ended up being 3.652 times 10 to the minus 10 coulombs, which, if summed over 10 pieces, gives a total charge of 3.652 times 10 to the minus 9 coulombs. To achieve this computational model, there were many assumptions made about the tape. To begin, I neglected air resistance and friction, instead solely focusing on the effects of gravitational and electric forces. Additionally, it was assumed that each piece of tape had an evenly distributed charge, which simply isn't the case in reality. A key difference from last week is that I'm no longer assuming that the charge on the tape is a point charge. Instead, I'm distributing the total charge into pieces. The experimental sources of error remain the same as last week and are equally as relevant in this experiment. So what if I had modeled each of the tapes as a single point charge, like in the previous lab? In the last lab, the estimated total charge of the tape turned out to be about 2.09 times 10 to the minus 8 coulombs. This was found by treating the entire tape as a point charge. This week, however, the estimated total charge was 3.652 times 10 to the minus 9 coulombs, and this was calculated by distributing the charge of tape into pieces. So why do these estimates differ? They differ for a variety of reasons. For example, the point charge estimate is derived from treating the whole tape as a single point, condensing the charge into the center of the tape. However, the distributed charge, while still not fully accurate, attempts to distribute the total charge of the tape across the tape. As a result, the distributed charge estimate is more likely to be closer to the real value of the charge because it more accurately represents the distribution of charge. Thank you very much for watching this lab report.